cosmic clouds of dust and gas collapse and swirl in a mesmerizing dance, giving birth to new stars. When the fuel runs out, the music slows, and the dance ends, even stars cannot escape their fate in this cosmic ballet. Our cosmic neighborhood, the Milky Way. Spanning a massive 100,000 light-years, our giant spiral galaxy is home to around 200 billion stars, each one cradled within its arms. While we may live in a quiet corner of this expansive galaxy, there's no shortage of wonders to behold. At the heart of our galaxy sits a supermassive black hole, a cosmic mystery, weighing in at a modest 4 million solar masses, in comparison to its counterparts in other galaxies. But the amazingness doesn't end there. The unseen hand that guides the motion of our galaxy is dark matter. This invisible substance, making up a significant portion of the universe, continues to confuse us, especially in its influence on star formation. Yet, some things never change in this vast expanse of the unknown. One such fact is the cyclical nature of stellar evolution. In their celestial dance, stars are born, live, and eventually meet their end. But in their death, they pave the way for the birth of new stars. A poetic testament to the universe's rhythm. Through the end, a new chapter of life begins. What happens to our star when it runs out of fuel? What's next when its bright light dims? Get ready for an amazing space story. Genesis of stars, the Milky Way's workshop. In the huge Milky Way galaxy, countless stars light up the night sky. On clear summer and fall nights, this glow is so bright it looks like a blanket of tiny lights, showing us the mix of gas and dust from which stars are born. This space dust contains metals like iron and silicone. When they come together, they create big clouds. Some are so big and dark that ancient cultures, like the Incas, saw shapes in them. One example is the Taurus Auriga clouds, which are close enough to give us a peek into where stars begin. These clouds are mostly made up of hydrogen and helium, but also have other molecules important for life. Next to bright stars, colorful spaces called nebulae, like the Orion Nebula, light up due to special rays from the stars. Stars are born in a chaotic way. As they grow, they first give off a soft, infrared light before becoming bright enough to see. Some stars, like T Tauri, shoot out powerful streams of energy that mix with gases and create shiny clouds, called Herbig-Haro objects. As stars get older, their hearts get hotter, starting reactions that turn hydrogen into helium and give off energy. Like the Pleiades, many stars group together in clusters, but eventually scatter. Our own sun might have been born in such a group, dancing and shining amidst a big cloud of dust. Stars of the main sequence, a cosmic dance. Like our sun, every star has a main phase where it shines by burning hydrogen. Most of the sun's energy comes from turning hydrogen into helium, but some of it comes from a complex process involving carbon. Even though they're called dwarfs, these stars can be very different in size. Some are much bigger than our sun, and some are as small as Jupiter. The most common stars are the red dwarfs. They make up 70% of all the stars in our galaxy. Then there are the brown dwarfs, which are somewhere between planets and stars in size. The NGC 6543 Nebula shows us stars changing as they get older. They shine brightly for a while, then cool down to become white dwarfs. Some stars are super bright, and others are very dim. The brighter a star, the shorter its life. The biggest stars last only a few million years, but the dimmest ones can shine for billions of years. Our sun is in the middle. It's been shining for about 5 billion years and has about that much time left. But our journey doesn't end here. Beyond our sun and galaxy, the universe is teeming with stories. Journey to becoming a giant star. In the vast cosmic theater, stars like our sun are actors undergoing thrilling transformations. After blazing brilliantly for 5 billion years, the sun's fiery energy wanes as hydrogen dwindles. And then, a magnificent metamorphosis begins. It grows, assuming the grandness of a giant, while its heart blazes intensely, turning helium into carbon. As carbon dances with helium, they birth oxygen. Ever witnessed a star's breathtaking finale? The Cygnus Loop Nebula captures the drama of a supernova, a colossal stellar explosion. From the fiery remnants, the universe's next generation of stars are forged. As they evolve, stars wear intricate cloaks of burning elements with their cores shrinking beneath. Some with such a rich mantle of carbon that they blush a deep red. Imagine stars so expansive that they could almost graze planets like Venus or Earth, radiating with a luminance that outshines thousands. Yet, even the mightiest of stars shed their majesty, unveiling a scorching core. Held firm by cosmic magic, these cores resist the crush of their own weight. In their wake, they cast off mesmerizing veils known as planetary nebulas. At their heart, a dense white dwarf forms. As these relics cool over eons, they stand as silent witnesses to the universe's epic tale. The ultimate showdown of massive stars. Imagine stars so massive that they undergo rapid transformations, changing hydrogen to helium and eventually forging dense metals like iron. They grow to colossal sizes, some so vast they could engulf even the wide span of Saturn's orbit. Enter Subramanian Chandrasekhar, a visionary who found that a star's heart has limits. When it weighs about 1.4 times our sun, it reaches a breaking point and collapses under its own weight. If it began life after heftier, with a weight of over 8 suns, it meets a spectacular end, a mighty Type 2 supernova explosion. The finale, a tightly packed neutron star, a flashing pulsar, or the mysterious abyss of a black hole. Stars in pairs or binary systems share a unique dance. They can swap or merge their masses, sometimes setting off brilliant Type 1a supernova fireworks. These cosmic fireworks are special, lighting up the universe consistently and brightly, allowing us to measure vast cosmic distances. Famous examples include the celestial wonders, named after Kepler and Tycho. The aftermath of these cosmic blasts is a treasure, debris laden with heavy elements. The stardust melds with cosmic clouds, sowing the seeds for new stars. And so, the universe's wondrous dance goes on. In all its magnificence, the universe is a complex ballet of stars being born, living out their destinies, and eventually meeting their dramatic ends. Each one a unique story, a testament to the universe's endless creativity. And now, a question for you. If you could witness any moment in a star's life, which would it be? The birth, the death, or somewhere in between? Drop your thoughts below and join the cosmic conversation. And remember, the universe is vast, and our journey through it has only just begun. Subscribe and stay with us as we traverse the celestial tapestry, one star at a time.